everyone. Of course, in my last lecture, I promised I was actually gonna make a video or where I'm gonna give an extensive explanation on the solutions to the midterm. Give me 1 second. I'm actually going to share the midterm one uh, right away. Okay, so I'm going to share the midterm one now. So this is the midterm one. Of course, the midterm one was actually reading last Friday. And of course, the results have been uploaded. And of course, I've already distributed the exam booklet to the students. And of course, the purpose of today's, you know, video is actually to explain, how questions in the midterm, are solved. Okay, so I'm actually going to start with, you know, um, I'm gonna start right now with question number one. We got 5 questions in all. So when you take a look at this particular question now, this is a question on, you know, what I'm going to call contingency table. So you actually have two categorical variables, education. Now, education has 2 levels, okay? And of course, this guy here also have 2 levels. And of course, anytime you are given something in a table like this, of course, that is giving you an impression that the variables under investigation are discrete in nature. Okay, so you know, we let A to represent the offender has 10 or more years of education, and B to represent the offender is convicted within 2 years after completion of treatments. And of course, so which means this is like what B represents, and this is what A, okay, represents, okay, in a way. Okay, so if A represent that and B represent that, and of course, Dave, if you take a look at the question, the question actually is centered on, A and B. Okay, it's centered on A and B. Now, find the probability of A. Okay, if you want to find the probability of A now, so you're actually talking about that guy. So the probability of A, don't forget I said that guy is A and this guy is actually B, based on what you see here. So the probability of A is adding this guy together, so which is 0.40. So the probability of A now is actually going to be this guy here. That is 0.40. So that is going to be the probability of A. Okay, so if you want to talk about, so in that situation now, so what I'm trying to say, the probability of A now, okay, is just going to be, normally the formula is the number in that divided by the totality. But right now, okay, so you can actually say, okay, the number in A is 0.40 divided by 1, so which is going to be 0.40. So the probability of A is going to be 0.40. And of course, if I want to get the probability of B now, the probability of B now, of course, I told you the other time, what B represent, right? The B represent convicted, okay? The B represent convicted. And of course, it's adding this guy together, the probability is going to be 0.37. Okay, so the probability of B, don't forget, this guy is B, right? Okay, so the probability of B is going to be, you're actually adding what you have, levels you have in the education, 0.1 plus 0.27, and that is a 0.37. So what I'm trying to say now, so this is going to be 0.37 and probability of A 0.40. Okay. Now, so you can see now, so the probability of A is 0.40, the probability of B is 0.37. Okay, so I need you to take notes of that. Now, what about the probability of, A intersection B? Okay, so if you want to find the probability of A intersection B, okay, now you're actually going to look at what number comes at the point of intersection between converted, okay, between A and B. That is 0.10. That's 0.10. As simple as that. Because this guy is A here and this guy is B, right? What is the probability of the joint, between, the probability of the joint occurrence of A and B? That's what you have now. So that's 0.10. Now, what about, so, if you take a look at what I've done now, like I said, the probability of A was found to be 0.4. The probability of B was found to be 0.37. Now, if I want to find the probability of A union B, okay, the probability of A union B is going to be equal to probability of A plus probability of B minus the probability of A intersection B. Of course, the probability of A is 0.4, so you're going to plug in 0.4. What is the probability of B? Is 0.37. And what is the probability of the interception? You've already gotten that in C. All what you're going to do is to plug that in. Okay, by the time you simplify, that will give you 0.67. Okay, so the probability of A union B now is 0.67. Okay, so A union B here, this is what we call non-mutually exclusive. Okay, I need you to take notes of that. Finally, I want to find the probability of A given B. Okay, the probability of A given B is just going to be the ratio of this guy to this guy. And you've already obtained the probability of A intersection B is C. So that is going to be 0.10 divided. What is the probability of B? You've already found that in question B. That will be 0.37. So when you find the ratio of 0.1 to 0.37, your final result for E is going to be 0.2703 at the end of the day. Okay, so that question is super easy. Okay, that question is super easy. Okay, so that is how question number one can be figured out. Okay, so you know, in summary, for probability of A, I got is 0.4. Just explain that. Probability of B is 0.37. The probability of A intersection B is 0.101 or 0.10. The probability of A union B is 0.67. And the probability of A given B is 0.2703. Okay, so that is the answer. Now I'm going to go into the next problem, which is problem 2. Okay, so when you take a look at problem 2, okay, problem 2 is actually on Bayes' theorem. Okay, now in problem 2, you need to false collect your data. It said out of those brought to court, there are 60% of which are actually uh, guilty. Okay, so the probability of that guilty, okay, is actually 60%. So if I write the probability, okay, of guilty now, okay, it's 0.6, okay, as given in the question. And of those that are guilty, 95% of them are confident, okay. I needed to take a look at that is the probability of convicted, given guilty. Okay, the probability of convicted given guilty is actually 0.95, which means 95% of the time, when offenders or accused is guilty, it's actually going to be convicted. Okay, going to be convicted. It is not on that doesn't occur 100% of the time because courts could make some errors. It is not 100% of the time. When offendant is guilty, it is not 100% of the time that they're actually going to be convicted. So this is giving 95% of the time. Now, but there are 1% of innocent people who get falsely uh, convicted. Okay, that's an error, committed by the court in a way. Okay, we're talking about 0.01, so which is going to be the probability of, convicted giving the complement of guilty. Okay, the complement of guilty is what we call innocent. Okay, so now the the probability of the complement of this now has actually been given as 0.01, as I mentioned. Okay, now the question now, what is the probability that you are innocent, given that you are convicted? Okay, the probability you are innocent, the innocent is going to be the complement of guilty. Okay, given that you are actually convicted, and of course that is going to attract what I call a Bayes rule. Okay, the probability of convicted given innocent, okay, multiply by the probability of complement of that, then divided by the probability of C given this, multiplied by probability of this, okay, plus, okay, the probability of C given G, then multiply by probability of G. So take a look at what we have right now. So that is the way the Bayes theorem is actually going to go. Okay, so you already have this guy to be 0.01, right? And if the probability of guilty is 0.6. The probability of the complement of guilty, the complement of guilty now is going to be innocent. That will be 0.4. Okay, because the two complement events are mutually exclusive, and that is why actually got that way. Okay, so I'm also going to have 0.01 here. Okay, then I'm also going to have 0.4, then plus. So what is the probability of C given J? Okay, that I'll be giving it to be 0.95. And what is the probability of guilty? Okay, the probability of guilty is 0.6. Okay, so now you're gonna do this guy multiply by 0.4. You're gonna do the same thing here. You're gonna do this guy here. By the time you simplify all of that, okay, you're actually gonna get your results. Okay, so let me start by using my calculator now. Okay, 0.01 multiplied by 0.4. Okay, 0.01 multiplied by 0.4 is going to be 0.004. And of course, we're also going to have 0.004, okay, plus. Then 0.95 multiplied by 0.6, that will be 0.57. Okay, that will be 0.57. So 0.57 plus 0.004, that will be 0.574. So I'm actually going to have 0.004 divided by 0.574. Okay, so 0.004 divided by 0.574. And finally, I'm actually going to have 0.007 approximately. Okay, the final answer now is going to be 0.007. Okay, that is how we're going to work that guy out. Okay, so I'm going to go into the second question. This question is on reliability. Okay, now the very first thing we actually going to do, okay, we can see that this guy is in parallel. Okay, now this guy is also in parallel. Okay, but when I resolve, this guy is going to be in series with this guy. Okay, when now these guys are also in series. So what I can do, okay, what I can do, I can of course, work on this guy now, resolving that. Okay, maybe they are in parallel, right? So, but it's my R1. Okay, R1 is going to be 1 minus, okay, 1 minus 1 minus 0.80. But because they are all the same, right? I can do raised to power 3. Okay, so when I do raised to power 3, then I'm actually that is gonna be equal to, when you simplify that guy now, that will give you 0.992. Okay, now the next thing is actually to also resolve this guy that's also in parallel. So I can just write R2, okay, reliability 2, 1 minus 0.70 squared. Okay, so my reliability 2, when I resolve that, okay, we actually give 0.910. Okay, now I've resolved my R1, I've resolved my R2. Okay, so what I'm gonna do now is to get and the R2 that we just resolved, okay, the R2 here is in series with this guy. Okay, which means if I want to get my R3 now, it's gonna be R2, okay, multiplied by 0.80. Okay, because they are in series. When they're in series, you're actually gonna multiply them out. Okay, so by the time we now have R3, what is the R2? The R2 that we got was 0.910 multiplied by 0.80, and that is actually going to give us a 0.7 or 728. Okay. Now, the next thing is actually to resolve this guy. Okay. Those tools are in series. Okay. I can actually call that R4. Okay. And when they're in series, all I'm just going to do is to multiply them out. Okay, so when I multiply them out, okay, I'm actually going to have 0.81. Okay, now the next thing I want to do, okay, the arrow 3 and arrow 4 are in parallel. If you take a look at what we have, okay, which means whatever I go here and whatever I go here, they are in parallel. Okay, now because they are in parallel, I'm actually going to do this now. So they are in parallel, like I said, R3 and R4 are in parallel. So I'm actually going to say my R5 is 1 minus R3, 1 minus R4. Okay, now which is going to be, plugging in what we got the other time. So 1 minus is 0.7 28 is what I go for R3. 1 minus 0.810 is what I got for R4. And when I do that, then my R5 is actually going to be 0.948. Okay, then finally, of course, we expect that everything here, after resolving that and everything here, after resolving that, they're actually going to be in series. And that is why I'm actually going to write the reliability of the entire system now. It's actually going to be R1 multiplied by R5 because they're going to be in series. Okay. All what I'm just going to do is, okay, zero, what I go for R1 the other time, I'm actually going to record that, multiply by what I got for R5, okay, and that what I got for R5 is 0.948. So by the time I multiply them out, the final result is actually going to be 0.940. Okay, so that is a final result. That is a final result. Okay, I'm actually going to move now. We'll move to question 3, or to problem 3. Now, when you take a look at problem 3, okay, I actually observed that some students have problem with calculus, and I need you to focus more on what I'm doing now. Okay, now this is the state space, and this particular probability density function is not completely specified because we need to figure out what is k. If I were to do this, you remember the law. Okay, f of x dx has to be equal to 1 over the state space. The state space here is from -1 to 0. Take a look at that. From -1 to 0. Don't forget what you're going to have in the lower bound has to be less than the upper bound. So when I have this guy now, what I'm actually gonna do, write this guy now, kx raised to power 4 dx equal to 1. Okay, now I want to figure out all the values of k. Okay, I can actually bring this k out of I can bring the k out here, and where I'm actually going to focus on this guy now. So I want to integrate x raised to the power 4. I want to perform an antiderivative on that. If I want to perform an antiderivative on that guy now, I think what I'm going to do at this point is actually to make use of, give me 1 second. I think I'm actually going to make use of uh, my whiteboard, okay, so that you'll be able to understand, this guy now. Just give me 1 second. Okay, so I'm actually going to stop my share. I'm actually going to share my whiteboard. Okay, I'm going to share my whiteboard really quick. Okay, give me 1 second while I share my whiteboard. Okay, this is my whiteboard now. Okay, now actually having k -1 to 0 x raised to the power 4 dx equal to 5 equal to 1. Okay, so equal to 1. Okay, now when I perform an antiderivative on this guy now, it's going to be raised to power 5, and this is going to go from -1 to 0 equal to 1. Don't forget, you got this guy here. So what I'm actually going to do now is to plug in wherever I see x, 0 raised to the power 5 divided by 5 minus, okay, a -1 raised to the power 5 divided by 5, or equal to 1. And of course, k into that will be 0, negative, if I have negative raised to power 1, -1 raised to power 5, that's going to be -1, and another negative is going to be that. I'm going to have this guy equal to 1, and of course, that is going to be k over 5. Okay, so k over 5 equal to 1. Okay, so what is your k? So your k is going to be equal to 5. Okay, so the final answer now is k equal to 5. Okay, so that is going to be the final answer, k equal to 5. Okay, so k equal to 5 is going to be the final answer for that. Okay, so I'm going to share my whiteboard again, and the other question is asking you to find the probability of x greater than half, or given that x less than that. Okay, and of course, if you want to do this, you remember what I always say about conditional, where we got the probability of a given b to be equal to this of divided by probability of b. So we'll be seeing this guy as a now, we'll be seeing this guy as b now. So in that situation, I'm actually going to have s greater than half. Okay, when I have S greater than half, intersection S less than negative 1 over 4, okay, divided by the probability of this guy now. But let me tell you, when you put into consideration the state space from negative 1 to 0, okay, there's no way we're going to have a situation where S is going to be greater than half. When you take a look at this scenario now, the probability of that is going to be 0 because it doesn't exist, you know. So we actually going to have this, which is going to be equal to 0. Okay, so that is how that guy is going to be computed. Okay, so I'm going to stop my share now. So I'm going to go into the next question. I'm going to share that with you really quick. So we're going into problem I think a problem 4 now. Okay, so when you take a look at problem 4, okay, if you want to solve problem 4, you know, I need you to actually pay attention to the table. I told you whenever you're given a table like that, you know, that will give you, you know, a kind of suggestion, you know, that what you have in your mind, where you're gonna have your mind is, oh, X is gonna be discrete, and you know, Y also gonna be discrete. So you want to take a look at this guy, say what is the conditional PMF of Y, okay, given S equal to 2. Okay, you know, if you want, you know, the interpretation of that is the probability of Y given X equal to 2. Okay, so which means, and don't forget, Y, okay, is going to be a random variable. The state space of Y is actually 0, 1, 2 as given. So which means I'm actually going to have 3 different results. You know, it means I'm actually going to have, you know, if I want to solve A now, I need to find the probability of Y equal to 0, given X equal to 2. Then I also need to figure out the probability of Y equal to 1, given S equal to 2. Then I also need to figure out the probability of Y equal to 2, given X equal to 2. Now, when you take a look at the 3 scenario now, you're actually gonna see that in each of the situation, X it remain true, but Y is changing, okay, because we put into consideration you know, the state space. Okay, so we got Y equal to 0, Y equal to 1, and Y equal to 2. Okay, so the next thing we actually going to put into consideration now is if I want to find the probability of Y equal to 0 given X equal to 2, remember conditional probability that I always talk about. The conditional probability of A given B is actually the probability of the joint, right? The probability of the joint divided by probability of B. So what does that mean if I want to figure this guy out now? Okay, so the probability of Y equal to 0 given X equal to 2 now is just going to be, well, the probability of X equal to 2, Y equal to 0 divided by probability of S equal to 2. Okay, I need to first figure this guy out. When S equal to 2, Y equal to 0. Oh my God. Take a look at that when S equal to 2 and Y equal to 0. Okay, so that is actually going to be 1 over 12. Okay, then divided. Now, what about the probability of X equal to 2? So if I want to figure out, okay, the probability of S equal to 2, I'm actually going to come here. Okay, S equal to 2 is that guy. So which means I'm going to sum this guy. Okay, I'm going to sum over the range of Y. You remember what I did in class when S equal to 2. Okay, so I'm actually going to have 1 over 12 plus 1 over 12 plus 1 over 6. Okay, now this is what I'm actually going to simplify. Okay, so when I simplify that, the result is going to be 1 over 4. Now, 1 over 4 for the conditional probability of Y equal to 0 given S equal to 2. I'm also going to do the same for Y equal to 1, S equal to 2 as well. So look at what I'm gonna do now. So if I want to solve the other one, I don't want to waste my time. I'm gonna just put one here. Okay, putting one here now. When I put one here now, so this guy's gonna be one. Okay, and now all what I just need, okay, is coming back to the table. Okay, when x equal to 2, y equal to 1, okay, that's going to be 1 over 12. So that's going to be 1 over 12 again. So when you simplify that guy again, you're still going to get 1 over 4. Okay, you're actually going to get 1 over 4. Now, the last one now is when y equal to 2. Okay, when y equal to 2, now I'm actually going to change this guy now. Okay, here to 2. Okay, now I'm actually going to clean up this guy. Okay, now what I need now is when from the table, when s equal to 2, y equal to 2, this guy, that's going to be here, right? It's going to be 1 over 6. And take notes, in all of that, I'm still going to have uh, the same value, that I have in the denominator. Okay, so when I simplify that guy, it's going to give me 1 over 2. Now, finally, if I want to write my result for A, it's going to be the probability of y equal to 0, giving x equal to 2, 1 over 4. The probability of y equal to 1, giving x equal to 2, 1 over 4. The probability of y equal to 2, giving x equal to 2 is 1 over 2. So, take a look at that. If you want to know whether you are right, if you had all this probability together, it should give you 1. Okay, so that is how to answer question A. Okay, that is how to answer question A. If you want to answer question B, the question B is going to be so easy because you know what it's asking? Question B here. So what is the marginal PMF of X? When you talk about marginal PMF of X, it's more or less like, okay, you know what? Um, you want to get X for 0, 1, 2. Okay, what is the probability of X? Okay, so when S equal to 0, I'm going to go into a table. S equal to 0 is right here. What am I going to do? I'm going to add this guy together. Okay, and what is it going to give you? 1 over 6. Because 1 over 6 plus 0 plus 0. Okay, see that? Plus, plus. That's going to be that. Okay, now if I want to do for x equal to 1, okay, I'm going to go to the next line. Okay, this over x equal to 1. I'm going to add this guy up, right? Okay, so 1 over 3 plus 1 over 6. That's going to give you 1 over 2. Lastly, for x equal to 2, for x equal to 2 is this guy. So which means I'm going to add 1 over 12 to 1 over 12 to 1 over 6. Finally, that will give me 1 over 3. Okay, so this answer question B. If you want to know whether you are right, all what you just need to do is to add 1 over 6 to 1 over 2 to 1 over 3, and that should give you 1. Okay, that should give you 1. Okay, I think I want to go to the last problem now. To go to the last problem now. The last problem is actually on, joint continuous probability. You are given an incomplete function specified. Okay, and what they ask you to do now, find the C and find the marginal PDF of both X and Y. Then after that, find what is the probability of X greater than Y given X less than half, and what is the conditional probability. And another question asks, are X and Y independent? I'm going to stop my share now. Okay, I'm going to stop my share so that I would be able to use my whiteboard. Okay, I'm going to be able to use my whiteboard. Okay, now you are given a joint f of xy to be c into x plus y, and of course, the range of x was between 0, 1. The range of y was between 0, 1. Okay, the question now asks you to find C. Okay, if I want to find constant now, so I'm actually going to have integral, or remember the formula, or dx or dy, okay, equal to 1. Okay, now I want to start with the dx. Okay, I'm going to use the range, 0 to 1, and 0 to 1. You can see that's already provided. So right now, so what I'm actually going to do is to actually write the given joint probability. So this is the x, the y equal to 1. So and I can bring my c out, 0 to 1. Okay, and I'm going to have x plus y. Okay, I want to start with ds first. And after starting with ds, when I perform the antiderivative with respect to x, then I'm going to make use of the boundary, and after that I'm actually going to perform an antiderivative with respect to y. Okay, so I'm gonna clean my board now, to have space. So I first want to perform an antiderivative with respect to x. Now I want to integrate with respect to x. So for first write this guy here. Okay, now with respect to x, I'm gonna have x squared over 2 xy, right? Okay, then over the range of 0 to 1. Okay, and don't forget, there's a dy, then equal to 1, right? Okay, so wherever I see s, I'm gonna plug in 1, right? Okay, so wherever I see s, I'm gonna plug in 1. Okay, wherever I see x, I'm gonna plug in 1. So 1 squared divided by that. Okay, 1 into y. Then I'm also gonna plug in 0. Okay, I'm gonna plug in 0. Okay, wherever I say x. Okay, now when I do that and I simplify, okay, so I want to simplify that guy now. Okay, now simplify this guy now. I'm actually gonna have 1 over 2 plus y, because all of these guys gonna be 0. Okay, so I'm actually going to have this, the y equal to 1. So now I'm now going to perform an antiderivative with respect to y now. So it's going to be y over 2 here, and y squared over 2 over the 0, 1, everything equal to 1. So what I'm going to do now, plug in 1 wherever I see y. So 1 over 2 plus 1 squared over 2, okay, minus 0 over 2 plus 0 squared over 2, okay, all equal to 1. So all of these guys is going to be 0. And when you take a look at what I have inside here, 1 squared is 1. So 1 over 2 plus 1 over 2, that's going to be 1. So I'm actually going to have, and 1 minus 0 is going to be 1. So it's going to be c equal to 1. Okay, so finally, the result for a, is going to be c equal to 1. Okay, c equal to 1. Okay, so with c equal to 1, I can now, go for b. Okay, I can go for b now. Okay, if I want to go for b, but before going for b, I can plug in what I got for the cost and C could be 1. So right now I'm actually just gonna have this guy, I'm only gonna have x plus y, okay, because our C equal to 1. And don't forget the state space, for x is this, and the state space for y is actually that. Now the second question is asking you to find the marginal PDF for both x and y. So if I want to get f of x, which is the marginal PDF of x, I'm actually going to integrate the joint with respect to the variable I'm not interested in. Okay, the variable I'm not interested in is actually y, and don't forget the range of y is going to be 0 to 1. So right now, so 0 to 1, plug this guy in. Okay, the y. Okay, so perform the antiderivative now. So it's going to be xy, so y squared divided by 2. Now over the, so when you plug in 1, wherever you see y, that is automatically, I'm actually going to have this guy 1 squared divided by 2. And by the time you plug in zero, of course, they're all going to be zero. So final here is going to be x plus half. Okay, the x plus half, that is going to be the marginal PDF of x. Okay, so similarly, I'm also going to find the marginal PDF of y. Okay, so if I want to find the marginal PDF of y, so what I'm actually going to do this time around is I'm actually going to come here. Okay, this is going to be f of y, but when that guy is f of y, of course, I'm going to perform the antiderivative with respect to x. If I want to obtain the PDF of y, then I'm going to integrate with respect to the variable I'm not interested in. Okay, so right now, so I'm going to have 0 to 1, x plus y, dx. Okay, so and when I have that, so it's going to be x squared over 2 plus xy, okay, using the range now. So wherever I see s, I'm going to plug in 1. So when I do that, I think this is going to be 1 over 2 plus y. Okay, so this is going to be your f of y. This is going to be your f of y. Okay, so you've gotten your f of y. Okay, when you take a look at the question C, I deliberately exempts everyone from question C. Okay, okay. I'm still going to give more information about that in class. Okay, so the next question, D now. D is actually talking about question D is talking about the conditional probability function. Of course, don't forget the formula is actually this divided by this. Okay, and this guy is x plus y that you've been given divided by f of x that you derive. I think we derive f of x to be x plus half. Okay, we actually, this is a conditional. You may simplify that, you may leave it that way, there's no problem. Now let's go to question E. Question E, are X and Y independent? Okay, are X and Y independent? There are so many ways, you can actually investigate this. Okay, for independence, if I'm able to express the joints as the product of the marginal, or if you take a look at D, if f of y given s is the same thing as f of y, we can actually conclude they are independent. When you take a look at this guy now, right? Okay, and if you compare to f of y that we got the other time, y plus half, obviously, this guy is not the same as this guy. So this guy and this guy are not the same. If they are not the same, it means they depend. Another way you can use to figure this out is the marginal you got the other time for f of x was x plus half, and for f of y is is a y plus half. When you multiply this guy together, it will never give you this. Never, because this guy was the f of xy or given. So here we're gonna say x and y are not independent. So not independent actually means they depends. Okay, so this is going to be the end of the review. Okay, this is the end of the midterm one, you know, um, review that I said that I was actually going to make. Okay, so make sure you watch the video, and tonight I'm actually going to upload the makeup exam one makeup. Okay, make sure you stay safe and have a lovely day. Bye for now. I'm gonna see you in class on Friday. So, bye for now, everyone.